Hey, hi, good day everyone. So today is our third session of our summary review of paper 2, number 2. So today the summary breakdown, excuse me, the summary breakdown is paper 2, number 7 question. Now, number 7 question, the topic I just put this in the centers. Now, in this, so number 7, right, is a question. The topic that is being tested on, the topic tested is your sequence, S-E-Q-U-E-N, sequence, is a sequence question, which includes a bit of algebra and a specific formula if the sequence is an arithmetic sequence, or if it is a square number. And I will teach you guys how to answer these questions. Now, one of the things that we need to learn about, let's just make this smaller because I don't need all of that, right? One of the things that you need to learn is the formula that I will give after, and then the next thing that you need to know is to recognize a pattern, because that's what these questions is, patterns questions, yeah? So the formula that you need to recognize in a pattern is not something I can help you with. You usually, to recognize a pattern, the first thing you check to see if is what type of numbers, right? I should type this down. Let's go to the next page. Let me right. So to RECOGNI, recognize a pattern, right? The first thing that you do is observe the numbers, right? Ask if it is increasing slash decreasing, right? And if it is increasing, is it by a constant term, or are the numbers increasing squared numbers? And squared numbers is typically numbers, the answers that you get when you put a number to the power of 2. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4, 5, 2, 3, 4. 4 squared is 16, 5 squares are 25, 6 squared are 36, 7 squares are 49, 49, not 79, 49. 8 squared is 64, 9 squared is 81, 10 squared is 100, then 121, then 144, then 139, then 196, right? And then I believe the next one is 225. That's 15 squared. Right, so if you see any of these numbers, you know that these are squared numbers that we're talking about. Now, to get that, if it's increasing by a constant term, how do you find that out? You take a term, it's a term, whatever the term is, subtract your previous term, right? And this must be the same for more than 2 times, right? And to observe a pattern, you ask is, well, you will see in the past paper questions, it's very easy to spot what is the pattern, right? The next thing that you need to remember, and this is very important, is if the terms are increasing by a constant, we can use this formula, and this formula is this this formula is very important, so please remember it. It is, hold on, is your nth term, whatever term that is, the nth term is equal to a1 minus n. Right, so your nth term, thank you very much, Celia. So we say an, or your nth term, whichever one you want to put, right, is, so you can put it like this: an is equals to a1 minus, or is it, no, it's plus n minus 1 by d. Okay. So what we have to recognize in this formula is certain things, right? One of the things is, what is an? An is your nth term. So you can look at whatever term, whether it's be your first, second, third, fourth, fifth. N is, it is whatever term, right? A1 is your first term. How do I know it is my first term? Because if you compare an with a1, you see that n is 1, right? So that's how I know it's my first term. If it was a2, it would have been my second term. A3, my fourth term. A4, my fourth term. And then n would be the term in question, whatever term we're looking at. If you are looking at your fifth term, then n would be 5. If you're looking at your sixth term, then n would be 6. Whatever term you're looking at for the question. And d is your common difference, F-F-E-R-E-N-C-E, which is your term subtract the previous term, right? And that would be what you have to learn. Now, once you remember this formula, you should be good. The only time this formula wouldn't work is if it is squared numbers. And that is why I say you have to recognize the pattern. Right? So that is about it for number 7. The first part of the question is to, usually they would ask you to write a diagram, to complete the diagram for whichever term. Then your second part of number 7 is to fill out a table. And then your third part is an algebra question, which is just you reading and understanding and trying to put into in algebraic terms what the question is asking. Right, so let's look at this question here. This is, by the way, January 2025. So this is, oh, hold on. Jan 2025. Right? You see the first diagram, the second diagram, the third diagram. Now, remember what I said. What is being increased? The square is being increased. And also they're adding 2 other dots to it, right? So we know if they ask you, so your first diagram has 1 square, your second diagram has 2 squares, your third diagram would have 3 squares. So obviously if they ask you for your fourth diagram, it would have 4 squares. Yes? So let me just, would it be able to do this? Hold on. Now you would have your ruler, so obviously this would be much faster for you than how I'm doing it here, right? And then if we recognize anything, we see that there are some additional dots, right? So one dot here and one dot here, and then a dot in the center here. And that is how your fourth diagram would look, right? Now, if we look at, so that was the first part to draw the diagram. Your second part, as I said, is usually to fill out a table, which we see here. The number of dots D and the number of unit lines that each form diagram L forms a pattern. The value of D and L for the first three diagrams are written in the table below. Study the pattern. So the diagram number, we have the number of dots and the number of lines, right? So we see that your diagram number would be whichever term we're looking at. If it is your first diagram, that would be your first term. Your second diagram would be your second term. Your third diagram would be your third term. Your fourth diagram would be your fourth term. Your nth diagram would be your nth term, right? That is how I want you guys to view this. When they say number of dots, we are looking at the pattern for number of dots. If we go from 5 to 8 to 11, so the pattern so far for number, let's just write this at the side and pull this here so I can have space. If we look at number of dots, number of dots, and we're going from 5 to 8 to 11, right? Is this increasing or decreasing? That's the first question you ask yourself. Go ahead. It's increasing, right? And by how much? Is there a common difference, or D? D is your term minus your previous term. What is your common difference? 3, right? So if we take one of the terms 11 and minus 8, you'll get 3. And you have to make sure it goes for the next one as well, right? So D is 8 minus 5, and we're also 3. So we know that D is your common difference, right? Let's just shift this to the side here. Guys, this class is going to be a little bit more interactive with you. Instead of me just teaching, I want to make sure that you understand it, yeah? So, right. So what is the formula that we're going to put here? So we have a common difference. We see it's arithmetic um, pattern, meaning it's increasing by a certain amount, right? So what are we going to be doing here? What is your formula for this? Very good. Now, I like to do, although we have part 1 and part 2 and part 3, I like to do part 3 first where I get the formula and then I could use it to get the others. Now, part 1 is pretty easy because they tell you the fourth term. So we know this would be plus 3, which is equals to 14, and then you could use your formula to check to see if that's correct. So let's go ahead and use the formula. So we know that D is 3, and what is A1? A1 is our first term in the sequence, which is 5. So we know that your nth term, which is this here, is going to be 5 plus open bracket n, because we're looking at nth term, minus 1 by d. Instead of d, you put in 3. So this will be 5 plus 3 by n, because when we see a number directly outside the bracket means to multiply the number outside by each term. 3 by n is 3n, and 3 by 1 is minus 3. So this would be 3n plus 5 minus 3 when I group like terms, right? So that's 3n plus 2. So that's the formula for here. Now, when n is equals to 4, because remember I told you that your diagram is your whatever term we're looking at, that's 3 4s are 12 plus 2 is 14. So we see that the formula does work to get your fourth term, right? Now, if you want to find for this part 2, when you want to find your diagram number, you just let this, because we're trying to find n, what n would be equal to if the number of dots is 59. So you say let 3n plus 2 is equals to 59. Carry this across, that's 3n is equals to 59 minus 2. So 3n is equals to, is it 7, 8, 9? Yeah, 57. If you carry across n over the equal sign, the opposite of multiply is divide. Sorry, not n. If you carry across 3 over the equal sign, that would be n is equals to 50. 57, sorry, it's 57. I was thinking about minus 3. Thank you very much, Sophia. 57 divided by 3, so n would be equal to 57 divided by 3 is 19. So my diagram number is 19 when the number of dots is 59. Do we understand that so far? So we have solved everything with number of dots. Let's look at number of lines. Alright, so let's go to the side here, and I'm going to do the working for that at the side here. We're going to look at number of lines. Look at those values. We have 8, 15, and 22. So number of lines, if the sequence is 8, then 15, then 22, is it an increasing sequence or pattern? Right, is there a common difference? So we're going to take, very good. So you're going to take a term, whichever term, and you minus the previous term. So 22 minus 15 is equals to 7, and then 15 minus 8 is also equals to 7. So you know that your common difference, or D, is equals to 7, right? And then you put it in this formula, or the formula that we use. The AN is equal to um, hold on, what's going on? A1 plus n minus 1 by d. Yeah? What is A1, guys, in this sequence of 8, 15, and 22? What is your first term? 8. Very good. So AN is going to be 8 plus, what is n? N, we don't know what n is. N minus 1 by a common difference of 7, which is 8 plus distribution law. When you have a number directly outside a bracket, you multiply by each term in the bracket. 7 by n is 7n. 7 by 1 is minus 7. So that would be 7n plus 8 minus 7. So that's 7n plus 1. 7n plus 1. What you could have done, we know that the common difference is 7. You could have just added 22 plus 7, 7, 8, 9. That's 29. Or you could use this, you know, it's your fourth term or your fourth diagram. So that's 7. 7 fours are 28, 21. 8 plus 1 is 29. Right? So you know, if you use your formula, or whether you add 7 to get, because it's your next term, you can do that. I would encourage whichever one that you want to do and you're comfortable with, go ahead and do that. Now, this one is going to be super easy. Why? Because we know that the term that we're looking at, n is equal to 19. So it's your 19th term, or you could say n is equals to 19. Same difference, right? So when n is 19, n is equals to 19. It will be 7 by 19 plus 1. You can do this in your calculator, or you can do it mentally. 7 by 19 is 133, plus 1 is equals to 134. 134. And that is the answer for this one. You have completed so far, and this is me explaining in 18 minutes. So I don't even think this took 18 minutes. This should not take you more than, let's say, 15 minutes to do, right? Because we have done the diagram and we did this, and this is with me explaining stuff. So this shouldn't take long to do. Let's look at part C. One of the diagram in the sequence has 148 lines. Calculate the number of dots in this diagram. So we know that number of lines, so number of lines is equals to 148. We want to find out how many dots. Now, to calculate how many dots, we need to know which diagram, or what is your n value. So we will use the formula for number of lines, which was 7n. 7n plus 1 is 148. So 7n, you carry across plus 1. Anytime you carry something over the equal sign, it's the opposite, right? 148 minus 1. So 7n would be 147, which is equals to 21. If I carry 7 over, it will be divided by 7. 147 divided by 7 is 21. I know that my diagram now is my 21st diagram, or n is equals to 21, same difference. So now I could find by my number of dots when n is equal to 21, the number of dots would be 3 by 21 plus 2. 3 twos are 3, 1 by 3 is 3, 3 twos are 6, 63 plus 2 is 65. So calculate the number of dots in this diagram. That would be 65 dots for that diagram. And that is how you would do this question. Okay, so this was May, June 2024. The diagram below shows the first 3 shapes in a sequence, which forms a pattern. Each shape is made using a set of small white counters and black counters. Complete the following diagram to represent the fourth shape. So if you recognize what is going on is they're adding on each side here. Yeah? So this was it, and they added, look at right here, they added one on this side and one on this side, and then they went up. So what you would have to do for this question is, alright, let's just get this. You'd have to add one on this side. 1, 2, 3, 4. 1, 2, 3, 4, and then you would add your black dots. One here, and then one here, one here, one here, one here, one here, one, and then one on top here. And that is how it should look. Did everyone get this? The number of white counters W, the number of black counters B, the total number of counters T, meaning when you get the number of white and you get the number of black, you add them up, right? That forms each shape follows a pattern. The values of W, B, and T for the first 3 shapes are shown in the table below. Study the pattern of numbers in each row of the table and answer the questions that follow. Complete the row mark 1, 2, and 3 in the table below. Now, when you have a question like this, right, and you have different numbers, you see how we have different numbers that come together to form that 6? Because if we look at 6 and 15 and 29, 1, they are not squared numbers, right? 2, difference between 6 and 15 is 9, and the difference between 28 and 15 is not 9. We see that there's an increase. So how this does not follow a constant. So we know we cannot just use the answer. So what we will do is we will look at each term and put it as a sequence. So you look at your first term. If you look at these, your first sequence is going to be 1, 2, 3. Next one is going to be, we see it's ones. The next one is twos. The next one is 1, 2, 3, and the next one is ones. Now, what we recognize, and even if you don't want to use it, we can use this here, do this here. We can recognize that your first set of terms in those things are your diagram number or your shape number, right? So this is n. Yeah, this is n. The next one is a constant. It's always 1, so it'll be plus 1. The next one would be 2, because it's a constant of 2, by your shape number, which is n, plus 1 again, because it's a constant. And that would be your answer for this. So far, so good with everyone. Do we understand that? This one here, sure, no problem. So, when you have different terms, you have in your section for number of white counters or number of black counters or whatever it is, and you don't just strictly have a number, one single number, you have a group of numbers like this. You deal with all the first terms in those sequences. So 1, 2, 3. Is there a pattern here? we can see that it is the same as your shape number. So if we're looking at your n term, you know that your first 1, right? You could have said your common difference is 1, right? And then your an would be a1, is it plus n minus 1 by d, right? You can do that. There's no, I'm not saying that is wrong. So an is going to be a1, which is 1, plus n minus 1 by 1, right? So we are going to get 1 plus 1 minus 1, 1 plus n minus 1, right? When you multiply this here and this here. So an is going to be 1 minus 1 is 1. So an is equals to n. So if you do put it in the formula, do I need to do it slower there? I think I kind of rushed that down. Do we understand how I got an is equals to, my n term is n? Or do I need to slow it down? Right. So this was your first terms in for number of white counters. Your second terms was 1, 1, 1, 1, 1. So we know that's a constant, so you're going to put 1 in the formula there. Same thing, 2, 2, 2, 2, 2. It does not change, so it's 2. This here, 1, 2, 3, you can use this formula as it. You saw that the common difference was 1. Your first term was 1. So you know that that would be 2. And we see it's 2 by n, which is how I got 2n. Right? Or 2 by whatever's in that bracket. And if working for whatever's in that bracket is the same thing here. So you could say this is the first term slash first, second, third, fourth. I'll say fourth term. Right? Then, so your second term is 1. Your third term is 2. Your fourth term would be the same thing. An is equals to n. So in your n term, n is n. And we see that it's 2 multiplied by that fourth term. So that's how I got 2n. And then your fifth term would be also 1. Do we understand this, guys? Now that I went through it step by step. Hello? Alright, great. Then we do the same thing. Now this is also for black counters. If you look, it's 1, 2, 3. We can also use this for the first term for black counters. You don't really need to, it does not change, right? So this is n. You saw for black counters, I'll just put BC, would be your first term is this formula here. So you get n is equal, an is equals to n. And then your second term, you see the second term is 1. Right? And you have that here. So far so good with us? And well, they gave us the third term. Are we good so far, guys, or are we confused? Anybody confused? Alright, great. So now we have our formulas. Let's work for this one. They told you if you use this formula, you're going to get 144, and they want to know the shape number, which is also n. So we have n plus 1 all squared is equals to 144. You carry across squared. What is the opposite of to the power of 2, guys? Very good. The square root of 144, which is what by what is 144? Very good. We want n to be the subject. If I carry across plus 1, that would be minus 1. So 12 minus 1 is equal to 11. So it would be my 11th term. So far, so good with everyone? I'm not going to go on this section just yet. I'm sticking on this one. I have this. I know that it's my fourth term, so it would be it will be 4 plus 1 all squared, which is 5 squared, which is 25. Yeah? Right. It looking like 40. Alright, hold on. It does. I can see how you can see it looks like 44 squared. Um, 4 plus 1. Yeah? Okay. Alright. Actually, you can make your 4 like this, but that's just weird. Anyway, um, then, so we use this. Right, let's use this one. So we know it would be your nth term is 11. So that would be 11 plus 1 in one bracket by 2 by 11 plus 1 in your next bracket. Did they put square brackets? They did. So let's solve that. 11 by 1 is 12. Multiply by 2 by 11 is 22. 22 plus 1 is 23. So 23 by 12, where's my calculator? 12 multiplied by 23 is 276. Right? And that would be the answer for this. Are we okay so far? Right. Now this one, you can simply, instead of using the formula, we know that the total number of counters, you add 45 and 25. That's 5 and 5, 10, 4, 5, 6, 7. So this is going to be 70. And that would be your answer for this. Do we understand? Or you could have taken 4 and substituted into this. So this would have been 3 by 4 squared plus 5 by 4 plus 2. You can put this in your calculator. 3 open bracket, 4 close bracket squared plus 5 by 4 close bracket plus 2. And you will get 70. Right? If you did do it. Go ahead. So you should show your working. For this, you would put above here, which I don't know how come they didn't give you a space to work, because they didn't really give you any. This is exactly how. Well, the only reason I would say to show your working is because just in case you made a mistake, the examiner could look at your work and be like, oh, this is where she made the mistake, right? They did give you work, and you didn't need to scrunch it up here. It has a whole entire underneath there, right? But I didn't want to keep on sliding up and down, right? But what I would say is label it properly. So put number of wide counters first term. This is the answer. This is how I got my first term is n. Second term is a constant, so you put 1 like that, right? Just label this is for number of white counters, and then number of black counters, you put the work in. Yeah? So just label it properly, I would say. Right. So let's look at this one. Let's read it carefully. This is 2 marks, so it shouldn't be too much working. The expression for the total number of for counters is you take your white and you plus it to your black in the shape S is given by your total counters is as squared plus bs plus 2, where a and b are both positive counters. By substituting suitable values for s, show that the total number of counters for shape 1 and shape 3 is this. So s is your shape number, right? So we're looking at shape 1, t, when s is equal to 1, right? When s was equals to 1, we saw that the 1 is 10, right? Hold on, let's just zoom in and I'll write that down. When your shape number was 1, your total number of counters from the previous diagram, your total was 10. So t is equals to as squared plus bs plus 2. So you're going to put 10 is equals to a by 1 squared plus b by 1 plus 2. So this would be 10 is equals to a 1a plus b plus 2. I carry across plus 2. This is how I got a plus b is equals to 10 minus 2. So a plus b is equals to 8. So I showed that one for shape 1. When s is equals to 3, right, I know my total was 44. So just zoom in. S is equals to 3. T was 44. So my T would be, again, AS squared plus BS plus 2. So 44 is equals to A by 3 squared plus B by 3 plus 2. So 44 is equals to 3 3s are 9. That's 9A plus 3B plus 2. Alright, carry this across over this equal sign. So that's 44 minus 2 is 9A plus 3B. Alright. This would be 42 is equals to 9A plus 3B. However, if you look at this, the coefficient of B is 1. How would you take 3B and turn it into 1B? You divide this entire thing by 3. So 42 divided by 3 is equals to 9A divided by 3 plus 3B divided by 3. Right? 42 divided by 3, my guess would be it's 14. 14. 3a divided by 3. 3 could go into 9 3 times, so it's 14 is equals to 3a plus b, and that is how you would show that for shape 1 is a plus b is equals to 8, and for shape 2, 3a plus b is equals to 14, and that would be your answer for this question. First off, what have we learned thus far? They can bring single values like this one, and you just apply it to your formula, right? Which is, if it's an arithmetic sequence, an is equals to a1 plus n minus 1 by d, right? And you just put it in and you'll get it. And the first thing that we do is to find your n term, and then we could work backwards to get whatever, right? The next thing we have learned, if there's a group of terms that has a pattern, you use each term. So it's your first term, you deal as those first terms as a pattern. Your second term, you deal with it as a pattern. Your third term, you deal with it as a pattern. Your fourth term in the question, you deal with it as a pattern, right? And that is how you would get this. Now let's look at this question. Same thing, right? Now this one here, what we saw is it's increasing by 1 in the black on top, and at the side also 1. So we know it is going to be, this is 2, this is 3, this is 4, so this one would be 5. 1, the black counters I'm talking about. 1, 2, 3, 4, 5, and then there's one clear one, and then 1, 2, 3, 4, 5. Hold on, we're increasing by 1, right? So 1, 2, 3, 4, 5 will be 1, 2, 3, 4, 5, and then we have a next one here, so it'll be 6, and then you fill it out with white counters, right? 1, hold on, let me, you're not seeing, sure, no problem. Let me zoom in and right, let's just zoom in, and it does have lines. So first off, we look at the black counters at the bottom. This one was 3, this one was 4, this one was 5. We see it is increasing by 1, right? So this one would be 6. So we have 1, 2, 3, 4, 5, 6. Look at the black counters going up. It's also increasing by 1, right? So this is 1, this is 2, this is 3, this is 4, so this would be 5. 1, 2, 3, 4, 5. Right? We see that above the 5 counters going vertically, there's one white counter, so it'll be here. Yeah, and then the rest is white. So 1 here, 1 here, 1 here, 1 here, 1 here. Right? And that would be the answer for your fourth design. Do we understand that, guys? Alright, let's look at this one. So this one is similar to what we have been learning in the previous question, where they don't just have one value, they have a series of values. So you treat all the first terms as a pattern, all the second terms as a pattern, all the third terms as a pattern, all the fourth terms as a pattern. So what is happening here? We are comparing it to your diagram number. We can see your first term is a diagram number. Your second term is also a diagram number. Your third term is also a diagram number, or n, and your fourth term is always 1. So this would be open bracket n multiplied by n plus 1, and you just leave it like that. Right? So if it's a 9 term, it will be 9 multiplied by 9 plus 9 plus 1. 9 nines are 81. 9 plus 1 is 10. So this would be 91. That is the answer for this. Are we good so far, guys? This one here, if they want to know the term number, we know that the first, second, and third numbers are our terms. So this would be 20. Do we understand this so far? Or your design number? Right? Now, this here, let's go. We're going 2, 4, 6, 8. So we know that this has, I'm going to do, if working for this, for your number of black, this, the pattern is 4, 6, 8. Right? So we see that there's a common difference. Your common difference is 2. 6 minus 4 is 2. 8 minus 6 is 2. Alright, so you're going to put it in an. Your n term is equals to a1 plus n minus 1 by d. So a1 is 4, d is 2. So your an term is 4 plus n minus 1 by 2. So an is equals to 4 plus 2n minus 2. So an is equals to 2n plus 2. When you group like terms, you'll get 4 minus 2, which is 2. So we know that the answer for n term is 2n plus 2. So when n is 20, that's 20 by 2 is 40. 40 plus 2 is 42. Then this one, 9 by 2 is 18. 18 plus 2 is 20. Right? And then we know that this fourth section, they told you the total number of this. So we're basically adding your number of white disk plus your number of black disk. Right? If you want a formula for it, you can add. So n by n is n squared plus n plus 1. And this is 2n plus 2. So this, the total number would be n squared plus n plus 2n plus 1 plus 2. I already grouped like terms, right? I have n squared, then n plus 2n, then plus 1 plus 2, which is n squared plus 3n plus 3. Do you understand how I got this formula for this, guys? Right. And then this one here would have been 421 plus 42, which is 3, 4, 5, 6, 463. And you could have also found out this value. Instead of putting it in the formula, you could have said 111 minus 91, and you will get 20. So you could have done that as well. This one as well. Hi. For which one? This one here? Sure, no problem. We know that this section is your total number of discs, which is your white plus your white disk plus your black disk. So I said n squared plus n plus 1 plus 2n plus 2. Group like terms, n squared, cross that off, plus n is the next n, yes, plus 2n, cross that off, plus 1, cross that off, plus 2. So that would be n squared plus 3n plus 3, and that would be your answer for this. Do you understand? Now? Right. Now, that is your second one, and let's go to the next page, which is Stephen has 28. Let's zoom in because, whew, hold on. So I'm not going to do all because some of these are quite similar, right? I am going to do a question that was a little bit different from the other years, and then we'll move on. Stephen has 28 black discs, so Black, let's write that down. Usually when I read a question, I usually read it first and then write down. But because we're pressed for time, black is equals to 28. White is equals to 154. And they want your N or your design number to be 12. Right? So let's find out. They said it is not possible. Explain why it is not possible. So when N is equals to 12, alright, hold on. When N is equals to 12, for white disk, we know it was, what was the formula, boy? N squared plus 2N plus 1, was that the formula? Yeah. And for black disk was 2N plus 2. Right, so I'm just writing it down so I can't so first let's find out how many white discs. White discs is equals to 12 squared plus 2 by 12 plus 1, which is 144, plus 12 by 2 is 24, plus 1, right? So 144 plus 24 plus 1 is, for white disk you need 169. Um, yeah, 169 white disk. We only have 154. So because it was 169 this needed for design 12 and only 154 white disk was obtained, or how much Stephen has, it will not be possible. For black you could do the same thing. That's 2 by 12, 24 plus 2, 24 plus, that is 24, plus 2 is equals to 26. So he does have sufficient black disk, but he does not have sufficient white disk to produce design 12. Do we all understand that, guys? No, 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 no. White is n squared plus n plus 1. Look at here. Hold on. Zoom, zoom, zoom. White disk is here. Black disk is here. Yeah? For white disk. Okay, hold on now. Let me I put 2n just now. Let's erase that. So that would be 144 plus 12 plus 1, 144 plus 12 plus 1 is 157. So they're still running short, right? Let me zoom up and I'll change that. So the formula here, take that off, take that off, take this off, and let's just, oh, and take the answer off. Right, so he had n squared plus n. So it'll be 144 plus 12 plus 1, which is 157. So we know that for design 12, 157 white disk was needed, and he only had 154. Thus, he would not be able to make design 12. Understand? Right, so these, very easy. I'm not going to do it because it should be easy to do. Also, if you look at my channel, some of these questions are already there. So this should be easy. This one here, this one here. All of these should be very easy because if you, once you apply the formula, you should be good. Right? I think the different one was this one here, which they brought in 2021 January. Right? So they didn't even ask you to draw any diagram. They went straight to this. Now, if you look at this, 5, okay, so number of dots would be easy. For your number of dots, is that similar? Number of dots would be 5, 9, 13, and 17. Your common difference there is 4. So you use AN is equals to A1 plus n minus 1 by d. So an, my n term would be my first term, which is 5 plus n minus 1 by 4. So an is equals to 5 plus 4n minus 4, which is 4n plus 5 minus 4, which is 4n plus 1. 4n plus 1. So your fifth term, you could either add 4, 17 plus 4 is 21, or you could apply it to this formula when n is 5, 5 4s are 20, 20 plus 1 is 21. So you get the same answer. This one here, pi is constant, so you leave it here. However, you look at your coefficients, 1, 4, 9, 16, 25. What type of numbers are these, guys? Anybody could tell me? Squared numbers, very good. So what is happening is instead of you using this formula, because there's no common difference, we know that those numbers are squared numbers, and it's squaring your figure number or your n term, right? So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So this would be n squared pi. So far so good? And then this one here, pi is constant, so we're going to put pi, but we're going to look at the sequence 1, 3, 5, 7. There is a common difference of 2, so you're going to put it, so an is going to be a1 plus n minus 1 by d. So an, hold on, that fan you're hearing, that's in the background. An is equal to a1, which is your first term of 1, plus n minus 1 by a common difference of 2. So an is going to be 1 plus 2n minus 2. So an is going to be 2n minus 1. So 2n minus 1 by pi, and that is going to be your answer for this. Now if you know that this is 5, you could have simply said 7 plus 2, 7, 8, 9 is 9, or you could say 5 2s are 10, 10 minus 1 is 9. So you will get whichever method that you choose, whether to apply to this formula or to just add 2 to it, you will get 9 pi. Now this here is the total length of circumferences of all circles. So we are adding, this has nothing to do with your number of dots, right? This will be 4 plus, so they're adding your figure number and your outer larger circle. So 1 plus 1 is 2 pi. 2 plus 4 pi is 6 pi. 3 plus 9, hold on. 3 plus 9 is 12 pi. 4 plus 16 is 20 pi. This would be 5 plus 9, which is 5 and 9 is 45. Hold on. Just now, I think I made a mistake. Um, yeah, just now, huh? I am saying we're looking at 2, 6, 12, 20, which does not have a common difference, and it's not squared terms. So you're gonna look at these terms and see how you'll get 2 pi. Right? We can say 1 plus 1, but if we look at 4 plus 3, 4 plus 3 is 7. So it is not your outer larger circle plus the area shaded, which makes no sense because they're asking you for the total length. Right? It would not. So what we're doing is adding your figure number and your outer larger circle. So 1 plus 1 pi is 2 pi. 2 plus 4 is 6. 3 plus 9 is 12. 4 plus 16 is 20. So this one would be 5 plus 25, which is 30 pi. Everyone seeing it? What did I do there? I took my figure number and I'm adding it to my area, the coefficient of the area of larger circles, which would be n plus n squared, all multiplied by pi. Right? So this would be n squared plus n by pi, and that would be your answer for this question. Do we understand? Right. I don't think that's the end. No, hold on. Is there next? Right. They had a B and a C. So it's usually a three-part question. So let's read. When the value, determine the value of n when the number of dots is. So they're asking you for the value of n when your figure number. Determine the value of n when the number of dots. So number of dots is 4n plus 1. So they say when 4n, they want to know what n is equal to when your number of dots is 541. So that's 4n plus 1 is 541. So 4n is equals carry across plus 1. That's 541 minus 1. So 4n is equals to 541 minus 1 is 540. So n carry across the 4 divided by 4. 540 divided by 4 is 135. So determine the value of n when the number of dots in the nth figure is 541. So n would be 135. Everybody good so far? And then we have write down in terms of p and pi the area of the largest circle for figure 3p. So area, let's look for area of your area for the largest circle. Area of the largest circle is n squared pi. So we know area. Let's zoom this up because I could barely see the question. Area of largest circle is equals to pi is n squared pi. Yeah, let me just make sure. Yeah, n squared pi. So when, and that is for if when your figure number is n. So they told you that your figure number is 3p. So when figure 3p, that would be 3p squared times pi, which would be 9p squared pi, and that is going to be your answer for 3p, figure 3p. Do we understand this, guys? Everybody understand? And that is the end for number 7, the review for number 7. So we will be doing number 6 shortly, the review for number 6. Past papers, paper 2.